Lewis structure. Let's go. This is very important topic. Please pay attention. It's so easy, but then it's left for you to know if you can grab it. From periodic table, this is introduction. From periodic table, from after carbon, we have nitrogen, we have oxygen, we have fluorine. I'm taking it easy from the introduction for you to understand the course. Now, immediately you move up to the left of the periodic table, you have boron, beryllium. Remember, this is from the right, we are going to the left. And so you have lithium. Now, I want you to know something. When you are counting, you will notice that this is under, that carbon is under group. It's under group 4. And this is 5. This is 6. And this is 7. Right? So the same thing, this place is 3, 2, and 1. So under the periodic table. Now, if this is from group 4 under the periodic table, it means that for it to attend either the octet or dual structure, it needs 4 more electrons. Because for it to be stable to attend the noble gas electronic configuration, as for its case now, the octet structure, it needs 4 more electrons. Is it not? Come to nitrogen. It already it's in group 5. So it already have 5 valence electrons. So for it to attend the noble gas electronic configuration, it needs more 3. Oxygen needs 2. Fluorine needs 1. Right? And so since fluorine needs 1 electron, in order for it to attend the octet structure, what it means is it forms only 1 bond. Note it down. That is an exam question. And oxygen, it needs 2 more electrons to attend the noble gas electronic configuration, and therefore it means that oxygen forms what? 2 bonds. Nitrogen needs 3 for it to be 8, and therefore it means that nitrogen forms what? 3 bonds. You are getting what I'm saying? If carbon have 4 and it needs more 4 to become 8, it means that carbon forms how many bonds? Of course, you know, 4 bonds. So that's the trick. Can you see? Now, remember, from carbon up to the right of the periodic table, they are non-metals. And then what non-metal does is they accept electrons. That's why they are negatively charged. Down from here, from carbon to the left hand side, they are metals. Metals give out electrons, and that's why they are what? Positively what? Charged. And then from here, if you do not understand this thing I'm saying right now, you may find it difficult under this course, in case you don't know it. Now, and I said, if this, of course, the number of bonds, this will 1, 2, 3, 4, right? Good. Now, we now said something. The number of bonds for metals, remember, this, it already have 1 valence electron, lithium. It's not going to accept, it's going to give out this 1 electron, and therefore the number of bonds it can form is 1. Beryllium will not accept, it will give out. Remember, metals give out electrons. So it's going to give out these 2 electrons. Therefore, the number of bonds this can form is what? 2. This will also give out electrons. The number of bonds it can form is 3. Good. Now, remember, I want to summarize Lewis structure in some few minutes. Now, from the group 3 of the periodic table, remember, from here I have phosphorus, sulfur, and I have chlorine here, right? Good. Now, I want you to know something. These ones here, we call them the expanded octets. They have expanded octet structure. Why? Let me show you why. Because by the time I go in depth into Lewis structure, I will talk about the expanded octet. I will talk about the incomplete octet. So that's why I'm taking my time to explain this thing right now, so that immediately you see it, you will be like, ah, yes. So phosphorus, or you can say sulfur, have an expanded octet. Chlorine can actually form one bond. It can actually form also more than one bond. Why? Because you have an expanded octet. Now, what am I saying? For the first rule, remember from energy quantization, quantum numbers, we say that if the energy level is 1, we only have 1x2, right? Good. And if you are in the first rule of the periodic table, the energy level is 1. And so you have 1x2. I hope you know electronic configuration. I'm trying to prove something here. On the second rule, n is equals to 2. So under the second rule, n is equals to 2. So you have 1x2, 2p6. So remember, this is the second rule, while this here is the third rule of periodic table. And so you can see that the total number of electrons here is 8. But under the third rule, we have 1x2, 2x2, right? And then 2p6. No. Under the third rule, I have 3x. Please, here should be 2x. So we are in the second row. Here is 2s2, 2p6. So here is 3x. Then you have 3p6 and 3d under the third row. So, and remember here, the total number of electrons here is 18. And so you can see that that is why these have an expanded octet structure, this compound. So phosphorus, sulfur, chlorine, all of them have expanded octet structure. Now, let's continue with the main theme proper. I want you to know something. Under Lewis structure, I'm taking my time here. This is 2 dots. Under Lewis structure, if I do something like this, this is 2 dots, right? So these are dots. And these 2 dots under Lewis represent one single bond like this. So each bond is made up of 2 dots. And so if that is the case, that means that double bond is made up of how many dots? It's made up of 4 dots. And therefore, triple bond is made up of how many dots? Of course, you get it, 6 dots. Are you understanding what I'm saying? Good. So like I said, 2 dots represent 1 bond, 4 dots is 2 bond, double bond, and then 6 dots under the structure is what? Triple bond. Are you with me? So that means that each bond here have 2 electrons. Let's continue. The next thing you need to know under Lewis structure is the formula we are going to be using. The beautiful formula we are going to be using, and that is that S is equals to V minus A. That X is equals to V minus A. Now, pay attention very well. This V and this A, they are all valence electrons. For example, let me bring nitrogen here. How many electrons does nitrogen need for it to be stable? It needs 8 electrons actually for it to be stable. The valence electron nitrogen needs is 8 for it to be stable, for it to attain the octet structure, right? Now, but nitrogen has already 5 valence electrons available. So how much does it need? How many valence electrons does it need? 3, right? So it have 5 valence electrons available. And that is when we come here. Now, this V means the valence electron it needs to attend the octet, the total valence electron it needs to attend the octet structure, which is 8. A means the valence electron available. Are you getting me? So here now, if I wanted to calculate X now for nitrogen, X for nitrogen, this will be the total number of valence electron it needs total is 8 minus the valence electron the nitrogen have is what? 5. And so you have 8 minus 5 to be 3. So the same thing, and if you want to understand this when it comes to V, just know that apart from hydrogen, every other element under this Lewis structure needs 8888. The V must be 8888 apart from hydrogen, because hydrogen actually what it needs is 2. Are you seeing it? So apart from hydrogen, every other element, nitrogen, this, oxygen, fluorine, you have to put it 888. But when you come to A, you will now talk about the valence electron, the available electron, which is for nitrogen, the A is 5, for oxygen, of course, is 2, and then for fluorine, you know. Do you know? For fluorine, of course, you know that it can only form one bond. I already said it here. Now, if it can form one bond, then what is the valence electron available? 7. Now, let's continue to the main thing proper. Let me drop questions because this is more interesting when you are actually looking at solved example. Now, from the top right hand side, you can see write the Lewis structure of the molecule, right? This. Now, this was what I was trying to explain. I said V is the valence electron required by all atoms in the species to attain the noble gas configuration. And then A is the valence electron available in all atoms, right? Good. Now, the first step into drawing Lewis structure is for you to know how to draw the skeleton first. And then how can you draw the skeleton? Is by actually your central atom has to be the least electronegativity element among it. For example, this right now we have CH3OH, and they ask us to draw it, right? Now remember from periodic table that electronegativity it increases as you go from left to what? Right across the period. Now from here, as you're going, look at from this compound we have hydrogen, right? Now in Lewis structure I say choose the one that it have least electronegativity. Don't go and say apart from hydrogen. Choose the element that have the least electronegativity apart from what? Hydrogen. Because if it is increasing from here, from left to right across the period, it means that you have to meet hydrogen first before you reach to carbon, right? So the exception is apart from hydrogen. So apart from hydrogen, what you will, the least electronegative element here is carbon, because you cannot say oxygen. Oxygen is more electronegative than carbon, right? So the first thing is for you to get the skeleton first. So that means your central atom has to be carbon, right? Now, when you're writing this, bear it in mind that carbon has the number of bonds carbon can form is what? 4, right? So this is it. So you can put hydrogen here. So this is hydrogen. We have 3 hydrogen, right? We have 3 hydrogen. Now, okay, let me put one here. Then the next thing is what? Oxygen. Then oxygen can, the number of bonds oxygen can form is 2. Remember here is number of bonds. I have said it before. So this is 1 bond, 2 bond, and then of course hydrogen can only form 1 bond. Alright? Now this is the skeleton. Now the next thing you have to do is, let me write this so that I'm not confused. we have CH3OH, right? So this is the skeleton. The next thing is you want to calculate this, get your S, so from here your V is, we have the total number of carbon, we have hydrogen, which is 4, we have carbon, so carbon is actually 8 plus, this is 4, so we have 2 times 4 plus oxygen is 8, because the double gas configuration of hydrogen is 2. That's why I said 2 times they are 4. Of course, carbon is 8. Like I said, apart from hydrogen, every one of them is 8, 8, 8. So you can see we have 4 hydrogen. I brought it out. This is carbon, which is 8. Oxygen is 8. So the next thing is for me to calculate it out. Right? So if you punch that in your calculator, what you should get is 24. So this will give you 24 electrons. Then the next thing is for you to get your A, the available ones. So from here, carbon have 4 valence electron available, plus of course hydrogen have 1, and we have 4, right? So 1 times 4 plus oxygen. How many valence electron does oxygen have? How many valence electrons does oxygen have? Oxygen have 6. So, and we only have 1 oxygen, right? So this is 4 plus 4 plus 6. So this will give you 14 electrons, right? Now, if you have 14 electrons, the next thing is for you to get your X. So from here now, we can get our X. I'm taking time. My subsequent video, I'm going to be extraordinarily fast. Now, the next thing is we want to calculate our X, and X is V minus A. And so your V is 24 minus 14, and that should give you 10 electrons, right? Good. Now, when you get this X, now the next thing is, out of this X, carry 4 pairs of electron and distribute around the central atoms. I think, let me not even draw this so that it will not confuse you. Let me just, the skeleton should be like this, without me actually putting anything. I thought this is how the skeleton should be. I think I made a mistake. This is how it should be. Now, once you get your X, the next thing you have to do is you have to carry 4 pairs. And 4 pairs means it's 8 electrons here. We have 10, and they say carry 4 pairs and distribute among the central atoms here. Right? So, and remember, each bond here is 2 electrons. So if they only say carry 4. So this is 1, 2, 3, 4, which is 8, right? Then immediately you distribute the 4. The remaining you can now distribute it in any other place that is not the central. So we have collected 4, which is 8, remaining 2. You can come here and put 2 here. Right? Now the next thing you have to do is we have to make sure, remember, carbon here can only form 4 bonds, hydrogen is 1 bond, but oxygen is 6. Oxygen will form 2 bonds, oxygen will form 2 bonds, but oxygen needs how many electrons to be stable? 8. Remember carbon, look at it, 4 bonds is stable, hydrogen 1 bond, they are stable, but oxygen is not stable here, right? So we have to put more 2 dots. Meaning what? Lone pairs. And now oxygen is stable. That means 1, 2, 2, 2, 2, making it what? 8. And so oxygen is stable. And this is the structure. Now, if you want to confirm your answer, the total number of bonds here, or the total number of electrons here, should be equals to A. Now, our A is 14 electrons here, right? So count it. We have 1, 2, 3, 4, 5, 6, 7. Each one is bond. So we have a total number of 14 electrons. Once you do your Lewis structure, it must be equal to what? It must be equal to your A. So that is it for this one. Let me go fast in other ones. Okay. Now Now the next one is HPO42 minus. Of course, from here, apart from hydrogen, which of it should be our central atom there? Which of it? Please guess on your own before I write it. Which of it should be the central atom? Now you can see that the least electronegative element here is what? The phosphorus. So the skeleton should be something like this. I don't want to draw the bonds. Pause the video, check it out on your own first. So we have 4 oxygen here, right? The first thing is for you to get the skeleton first. I have 4 oxygen here. If you want, you can put your hydrogen somewhere here. So this is a skeleton. Now the first thing you have to do is for you to get your V. And V is, I said, apart from here, which is 2, every other one is 8, right? So you have 2 plus V is 2 plus, this is 8, right? Then we have plus 4 times 8, that of the oxygen, right? And here is minus 2, so it has to be plus 2. And so this should give you your V. This plus this should give you 10. This plus this 16 times 2 times 4. So that should give you, your V should give you 42 electrons. Now time. V is 42 electrons. Then the next thing is for you to get your A, right? So from here, the valency here is 1 plus here, because we have 5 plus, please, I'm not supposed to add 2 here. Please, I'm not supposed to add 2 here, but this is the one for noble gas. So this is 1 plus 5 plus 6. Oxygen is 6 times 4. This is where I'll add the 2 plus 2. Please pardon me. You should punch it in your calculator. Your A is 32 electrons. Your A is 32 electrons. And so your S, which is V minus A. So your V, which is 42 minus 32. And that should give you 10 electrons. Now remember, you are to pick only 4 pairs of electrons, which is what? 8, right? So, and then distribute around the central atom. This is central, not here. This is central. So distribute that 8 electron around here alone. Then the remaining one, you can distribute to the remaining atoms, that if there is any available one. So this is 1. So I've already picked. So this is 8 electrons, which is 4 pairs. They say we should pick. Then the next one is the remaining 2, which is this, right? Now, is this equation balanced yet? No. Of course, we have to balance it. Now, look at this place. We only have 1 bond attached to oxygen, right? And oxygen needs 8. So this is only 2 electrons. So it needs more 6 electrons, right? It needs more 6 electrons. So this is it. It has to be in dot because that means it's lone pairs. It's not involved. So this is the dot. This is the dot. Because we here have 2, which is 4. So we need more 4. So this is dot. And then this is balance. So of course, this should be like this. 2 minus. Under the subsequent video, we're going to be talking about formal charges, how to calculate formal charge. We are still in Lewis structure. This is part 1 of the video. So, of course, if you should count all these things, it should be equal to your A, which is 32. So if you should count this, all these bonds that are here, it must be equal to 32 electrons. Do you have any question? If you have any question, please kindly drop it on the comment section there. So that is all there is actually about this whole Lewis structure. Let's meet in part 2 of the video.